Hello there, 7th graders. So, today we have a lesson on Chapter 5, Lesson 2. We're going to start out by going over a little bit of vocabulary for it. So, I've got the first vocab term for this. We're going to be learning about what we call arithmetic sequences in this lesson. And so, our first word is a sequence. Now, a sequence is pretty simple. It's just an ordered list of numbers. So when you have a list of numbers that are put in a certain order, that would be a sequence. Now, our second vocab word is term. A term is just a number in that list of numbers. So if I have a list of numbers 5, 6, 7, 8, 5, 6, 7, and 8 are the terms in that sequence. My third term here is an arithmetic sequence. Now, an arithmetic sequence is a sequence or list of numbers where each term is found by adding the same number to the previous term. Now, this will make a little bit more sense when we look at an example of an arithmetic sequence. So let's look at an example of an arithmetic sequence. So here you can see on my whiteboard, I have a series of numbers. I've got 8, 13, 18, and 23. This is an example of an arithmetic sequence. So I have the term 8, the term 13, the term 18, and the term 23. Now, to make this an arithmetic sequence, to get the second term in the sequence, I have to add a number to the first term. Okay, so the number I was adding to get from 8 to 13 is 5. And to get from 13 to 18, I added 5. And to get from 18 to 23, I added 5. This is an arithmetic sequence. We're adding the same number over and over to get the next term in the sequence. So if I wanted to get the next term in this sequence, I would add 5. And my next term in the sequence would be 28. So this is an arithmetic sequence. Let's take a look at another example. Here we have a second example of an arithmetic sequence. In this arithmetic sequence, we're going to look to see what is happening or describe the arithmetic sequence. So our first term is 0.4 and our second term is 0.6. So I've had to add something if it's going to be arithmetic. If I was timesing or subtracting, it's not arithmetic. So I have to add something. Now, 0.2 plus 0.4 would get me 0.6. So I am adding 0.2 or 2/10 in each case to get the next term. So if I wanted to find out the next two terms in the sequence, I would just add 2/10 to 1, so that's 1.2, and 2/10 to 1.2 would be 1.4, my next two terms in this arithmetic sequence. Okay, the next thing we're going to learn how to do is we're going to learn how to write an algebraic expression to represent an arithmetic sequence. So here we've got an arithmetic sequence, 2, 4, 6, 8. In order to write an expression, we have to think about the position of each number. For example, 2 is the first term in the sequence, so it is in the first position. 4 is the second term in the sequence, so it's in the second position. 6 is in the third, and 8 would be in the fourth position. Now, I need to understand the position because that's going to help me find my expression. So, to find my expression, or to help me find my expression, I'm going to create a table really quick. Okay, so I've got my table. And now when I look at my table, I'm going to have 3 columns. The n column, the operation column, and the value column. Now, n is the variable that I use to represent the position in the sequence. So n is the position. So in this particular sequence, I've got position 1, 2, 3, and 4. Because 2's in the first position, and 2 and 3. I don't really need the 4 right now. Now, what's the value at the first position? Well, the value at the first position is whatever number I have first in the sequence. So that's 2. My second position is 4. My third position in the sequence is 6. Now I have to fill in my middle column, and this is the column that's going to help me write my algebraic expression. What I'm going to do is I'm going to take the position that I have, 1, 2, and 3, and I'm going to perform an operation on that position so that it gets me the value that I'm supposed to have. Now, to help me figure that out, I'm going to look at what's happening each time in this sequence. In this sequence, if I described it, I'm adding 2 each time. Now, if I come down here and take my position number and add 2 to it, it's going to get me 3, not 2. So that doesn't work. But if I think about it, 1 times 2 would get me 2. And 2 times 2 would get me 4. And 3 times 2 would get me 6. So, now that I've got my position numbers figured out and I know what I'm timesing them by, now I can write my expression. Each one of these was times by 2. So I'm going to write 2 times. And what was I doing? I was timesing the position number by 2 each time. Now for an expression, I'm going to need an algebraic expression. I'm going to need a variable. And I already know what that variable is going to be. I'm going to use the variable n because it's the variable that I use for the position numbers. So instead of writing 1, 2, or 3 times 2, I'm just going to say 2 times the position number, or n. And now, I could write it like this, just 2n, I don't need the dot. And here is my algebraic expression for the arithmetic sequence 2, 4, 6, 8. Now, here's how this can be helpful. Let's say I want to know what number is going to be the 10th number in this sequence. All I've got to do is, if I know my algebraic expression for the sequence, then all I do is replace n with the number that I want. I want the 10th number, so I'll replace n with 10, and the value of the 10th number is going to be 20. Let's look at another example. Okay, here's our next example. We've got 4, 8, 12, and 16. And I know that I've got position 1, 2, 3, and 4, so I'm going to fill those in on my chart for the position numbers. Remember, n is the variable we use to represent the position number. Now I'm going to fill in the values. First position, it's 4, and second is 8, third is 12, and fourth is 16. To help me figure out my operation, I'm going to look at what operation was happening up here in my sequence. I'm getting a plus 4 each time. Now, like the last one, I'm not actually going to be able to add plus 4. 1 plus 4 gets me 5, and it's supposed to equal 4. But position number 1, 1 times 4 does get me 4. And this one, 2 times 4, does get me 8. And 3 times 4 does get me 12. And so, I know that each time I'm multiplying by 4. So to write my expression, I'm going to say 4 times the position number. Now, so that I can make it be any number I want, I'm going to use the variable n instead of the position number that we used in here. So I replace my position number with n, and I get the expression 4 times n, or 4n. There's my algebraic expression for n. Now let's say I want to know position number 12, or the 12th number in the sequence. The 12th number in the sequence would be 4 times 12, because I'd replace the n with the position number I want, 12. And that tells me that the value, or the 12th number in the sequence, is going to be 48. Let's look at a more challenging example. Okay, here's our next example. I've got the sequence 5, 8, 11, 14. Now, my first number in the sequence is 5. Second number is 8. Third number is 11. Fourth number, 14. So those are my values. Now, to help me write my operation, I'm going to, once again, figure out what was happening up here in the sequence. And I was adding 3 each time. So that's going to help me write my operation. I'm going to say 1 times 3, because I know that that 3 is going to tell me what I'm timesing by. So I'm doing 1 times 3, but 1 times 3 only gets me 3. My value is supposed to be 5. So what would I need to do to 3 in order to get 5? Did you figure it out? All I've got to do is add 2. 1 times 3 gets me 3, plus 2 gets me 5. Now let's see if that works on our next one. Position number 2 times 3 gets me 6, plus 2 gets me the 8 that I'm supposed to have. 3 times 3 plus 2 does get me 11. And 4 times 3 plus 2 does get me 14. So, I know what I had to do there. Now I think about it for writing my expression. What did I do each time? Well, I was timesing by 3, so I'm going to write 3 times, and I was timesing 3 by the position number. So I'm going to replace the position number with the variable n so that it can be any position I want. The last thing I had to do was add 2. So I'm going to say plus 2. And my equation becomes 3 times n, or 3n, plus 2. Once again, let's say I wanted to know what the 21st number in my sequence is. What I'm going to do is do 3 times 21 plus 2. That gets me 63 plus 2, so the 21st number in my sequence will be 65. And that's algebraic expressions for an arithmetic sequence. I'm going to post a question about algebraic expressions in Google Classroom, so be looking out for that. I'm going to give you a list of numbers or an arithmetic sequence, and I want you to tell me the algebraic expression that would represent it. Hope you had some good learning happening here. It was nice to talk to you, even if I couldn't hear you guys talking back. I miss you.